So looking at the worksheet on volumes by revolution, 4A, job 1 is to draw the base area. So the intersection of sine and cosine, x is greater than 0 and x is 0. Okay, so there's my base area. Base, axis, reflect, and circles. Around the x-axis. That's probably our favorite thing to rotate around because it's the easiest thing to rotate around. All right, to draw the reflection. It's a fun looking picture. And then the circles to make it look 3D. So disc or washers for this problem? Washers, so I'll need R and R. I'm going to go ahead and start the integral. Pi times integral of big R squared minus little r squared. And remember, that's okay as long as you've properly identified big R and little r. Are they stacked up dx or are they stacked up dy? Or what's the thickness of those washers is dx, which means my limits need to be in the x direction. So my limits of integration from what to what? Intentionally misleading there. So from what to what for the x limits? 0 to pi over 4. Okay, now I need to figure out big R and little r. Big R. Big R. Is big R constant or changing? Changing. Not much by my picture, but changing. What's big R equal to?
Cosine x.
That's the cosine x. It's equal to y2, which is cosine of x. And little r, that's equal to sine of x. And that is all the work you need to show. I mean, you need to type it in a calculator and get a number answer, but that's all the work that you need to show for me or for AP. So in the calculator, 0 to pi over 4, cosine of x squared minus sine of x squared dx, and then whatever number you get would be your answer. Questions on that one? All right, 4B. So same starting picture. Root 2 over 2 is like 0.7, so I guess I should have done a better job of that the first time around. So there's sine, there's cosine. And it's okay to take a little time to make your picture look nice. So there's the base area. The axis of rotation is y equals 1. Then let's reflect my picture across that. And then draw the circles to give the 3D effect. Yeah, take your time drawing it, because if you draw it right, you're much more likely to get the disk washer question right, to get the R's right, get the dx versus dy right. So don't rush through the drawing.
So V is going to be pi the integral between.
Let's just jump to the end here. Are they stacked up x or y?
It's going to be dx.
It's going to be dx. So that points to me having x limits.
0 to pi.
So 0 to pi over 4 again.
R squared.
And it's a washer, so r squared minus r squared. Now we just need to correctly figure out who's big R and who's little r. Anytime your axis is not on one of the x or y axes, you're going to have a little bit trickier time for big R and little r. There's big R, the outside radius. There's another big R if it helps to see. It's changing. Well, let's figure out what big R is first. So it's related to sine x, but sine x is this. Is that distance. Big R is not that distance. Big R is related to that distance. Cosine minus sine would be the height of the little piece there.
I think it's.
So it's not cosine minus sine. It's 1 minus sine of x. And then little r similar.
1 minus cosine of x.
1 minus cosine of x. And then we're ready to go to the calculator and type it all in.
So is this considered a washer problem or a disk and washer problem? Because the base would be a washer, or would be a disk.
You're right, the base is a disk, but it's the only disk, right? So it's a washer problem. But I see what you mean. Same thing over here. The base is a disk, but it's the only disk. More complicated pictures, if it's like if there was an extra something on the end of this, you would have to break it into two integrals, where you'd have the disk problem plus the washer problem. Questions on B? Yes, sir?
So I'll save for after class.
Okay. Part C. All right, 4C. Same base area, so there's sine, there's cosine, and remember the pictures look different because the scales are different, but that's the same shape, or the same base shape as A and B. Rotate around the y-axis. So let's draw the picture onto the other side. Oh, something. They are disks.
So no little r.
So no little r. Don't put an x there, right? Because then you might think that the x is the variable. So don't x it out. Leave it blank. Put a 0, write NA, but don't put an x because then you might confuse yourself. Okay, these are pi. Are they stacked in the x or in the y direction?
Y direction.
The y direction. Well, something's going on at root 2 over 2. That's where they intersect. This is a tricky one. So I need to go 0 to 1. I need to go all the way. But it switches. Like I have two different r's for this problem. So
split them at square root 2 over 2.
I'm going to have to split this at root 2 over 2 because my r changes. Who r is changes at root 2 over 2. So I need to go 0 to root 2 over 2 of r1 squared. And then root 2 over 2 to 1 of r2 squared. Because those are different r's. So r1, like the first thing I see is that it's an x distance, it's a left-right distance. But that doesn't really help because I need it in terms of y. Let's see, that bottom one was y equals sine of x. I'm glad we picked this one. It's a tricky one. So what does x equal if y equals sine of x? What do I do to undo the sign is inverse sine it. So x equals inverse sine of y. So r1 is inverse sine of y. And r2, also an x distance, but it's inverse cosine of y. So that would be a very ugly one to type in. It would be an impossible one to do by hand, but that's why you have a calculator. This isn't I mean, that's kind of a safe stop, but you haven't answered the question yet. You've shown enough work, but you would still need to put it in the calculator and get, whatever the answer is.
So wouldn't the disk at y equals square root of 2 over 2 double because it's in both equations?
So good question. At root 2 over 2, like which are you double counting it basically? Because it's in this one and in this one. Kinda, but how thick is that disk?
Really skinny.
Really skinny. Its thickness is dy, which is like infinitely thin. So it only matters when you add up all of them. If you just have one of them, its volume is 0 because it's infinitely thin. The volumes don't add to 0 because there's so many of them. But it's a good question. Are you double counting that disk? Arguably yes, but since its width is 0, you're fine. And there's no other way to, right? You can't say root 2 over 2 minus a little bit, root 2 over 2 plus a little bit. Like you got to go to root 2 over 2. All right, good questions. I posted different ones earlier, so you can check those out if you want to see more. Plus, we'll do more of these tomorrow.